Hello and welcome to Flat Earth Math's first live broadcast. This is Charles Breeling. I'm just messing around here. Um, just basically, I'm going to be testing out my first experience with starting my own live streaming. And ideally, what I would like to do is once a week have a chat with a flat earther, a nice civil conversation. So maybe we'll start that next Saturday. I'm not quite sure. I'm still tossing around ideas about the format, but right now I don't even know how this thing works. So I'm gonna take a look at my channel. Let me see here. Yeah, it actually says somebody's watching, so I just want to take a look at see if there's any chat action, because I would like to pay attention to the chat, especially since this is my first time doing this. I don't even know. Oh, hello, Worm Victory. So basically, this really is just a fake. This is a fake hangout. I'm just here. I'm just going to be, moving my gums around. Maybe you'll talk a little bit about perspective. But I also would like to interact with anybody who happens to be coming by the chat. So hello, Worm Victory. So perspective. Perspective, I think, has sort of been a buzzword among flat earthers for a long time. And I've followed Nathan Oakley's debate channel, where they like to scream at anybody who's a glober who doesn't kowtow appropriately. But basically, they seem to get perspective 100% backwards. So let me see if I can just try to play with my windows. I think probably what I need is an external monitor. Let me pop out chat, because when I'm at school, I teach in a cyber school. And there's Imric. Imric, you are first as usual. Oh my goodness. All right, so what am I doing here? I am trying to go to Safari. So I've recognized that a lot of people, they get their hangouts like sniped and stuff. And so what I decided to do is use a different browser. So hopefully you guys can see. Does that work? Yep. Oh, it's very slow. Okay, you guys are delayed about 5 seconds from what I'm doing. Hello, Mr. M. Oh my goodness, this is really a new experience for me. I know it's like 2018, and I'm just now learning how to interact with this thing called the interwebs. It's a series of tubes. Anyway, so perspective. It seems that Nathan Oakley and crew have discovered that there is actually a formula for angular size. And this is my favorite angular size calculator. And what's interesting about this calculator is that there are three variables, or there are three quantities that have a relationship. And they are distance, size, and angular size. Okay, distance, size, and angular size. And this calculator is really, really nice because it's super robust. The thing about any kind of mathematical formula that has, say, three variables in it is, if you know what two of the variables are, you can solve for the third variable. Okay, so if you have a formula, it has three variables in it, you can solve for the third variable. So this calculator is really nice in that if you know the distance and the size, that's the traditional way. Oh, find the angular size. I mean, that's the name of the calculator. If you know the distance and you know the size, it will calculate the angular size. Okay, it's a pretty simple trig formula. I'm not going to go into it now because I don't actually have my my pen tablet here. It's actually upstairs in the baby's room. And Imric says he was an angular, but you just hunt now instead. All right, so no more fishing for you, huh? Imric, it looks like you got a makeover. I like the hair, and the jacket is smashing. So what I really like about this calculator, well, there's two main things. One is you can solve for not only angle, but you could also solve for distance or for size. So if you choose that you want to solve for angle, then it plugs in that you need to type in the distance and the size. And the thing is, the units can be any units at all, as long as they're units of length. So you can have it be in centimeters, or you can have it be in miles or feet or meters, or any unit of length. All right. Oh, there's the Limitless channel. uh, okay, so this has nothing to do with R. And wow, we've got a celebrity, Dazza the cameraman, all the way from the land of the Kiwis. So Dazza, when my father turned 80, us kids got together and we got him a we got him a trip to New Zealand for my dad and my mom. And it was through a group called Elder Hostel. They've now changed their name to Rhodes Scholar, which is the silliest name. Yes, Middle Earth, absolutely. So it was basically, I think it was like a 10-day trip to both islands, and a significant portion of the trip was on a touring cruise ship that kind of like hit ports of call, and they just saw all the sights, and they were really marveling at how the North Island was like an entirely different continent from the South Island. And yeah, they had a tremendous time. So Dazza the cameraman, at some point I would like to get to New Zealand. The Limitless channel, the angular size has nothing to do with R. And angular reduction really is, if you have something that is further away, then obviously the angular size will reduce. All right. Yeah, they rotate in the opposite direction. Dazza, sometimes people, they talk about the opposite direction, and they're like, oh, so you're saying that the stars don't rise in the east, And so it's so funny how the word direction, you could misapply that word. That's one of the favorite tactics of flat earthers. Looks like we've got Tim Osmond in the chat. Angular size proves flat earth. But anyway, I'm going off on a million tangents here. So anyway, angular size calculator. So the thing that gets me about the talk over at the Nathan Oakley show is that they are using, let me just go to the actual the infamous Earth curve calculator over at Metabunk. Metabunk, Earth curve, Metabunk curve. And hopefully you guys can see this. And hello, Alex. Cheers to you. Okay, so what really is bugging them is this diagram, which is orthographic. And orthographic is just a fancy name for side view, but not a perspective side view. So this is side view where the observer is 1,000,000 miles away. So zooming at looking at this through a telescope. So the side view, but you can actually measure angles. I'm sorry, you can measure angles. You can measure heights of things. Everything is going to be accurate. Oh, it looks like they've added a couple of he's added a couple of new lines here. So, oh, okay. Alex. Yes, we're going to try to keep the chat clean anyway. But this is an orthographic view, and one of the things about this view is that you could measure something over here on the left, the height. Oops, didn't mean to zoom in like that. The height, you can measure the height of, say, where the camera is, whether you're at the top of a building, whether you're on a cliff, or you have some sort of elevated lookout view. But then you go over here to the right, and you can actually measure a similar height over here, in which case you may have drops. So right now the hidden value is just that little bit in red. Okay. And what the Nathan Oakley crew, no, that's quite all right, Alex. I appreciate that. What the Nathan Oakley crew doesn't seem to get is that since this is a side view, we are comparing apples to apples. So to the observer, who's way over here, to the observer, yes, things in the distance appear smaller. but we are looking at it from the side. So you can actually compare apples to apples. So if the drop is, say 100 feet, that's 100 feet as viewed from the side. Now, the observer, the drop of 100 feet, it won't look like 100 feet because it's far away. So the thing that is really, really funny to me about this whole debate about perspective and about how this calculator, this horrible, horrible calculator that by that horrible man, Mick West. Oops, I'm trying to. I have no idea what's happening. I don't normally use Safari, so I think I just zoomed in. There we go. So all this thing is it's just a calculator, and what the Nathan Oakley crew doesn't understand is that anybody could write the calculator. You could just a bit of code. You can actually do the same thing with a spreadsheet. And not only that, but you can actually plug in any value of radius you want. So you can actually make a basketball curvature calculator, and you just plug in the radius of a basketball, or you could do it with a beach ball, or anything else. You could do a Mars curvature calculator. Charlie says, "What if you're upside down?" Yes, you have to, I don't know, have something to hang on to. But the funny thing about this whole debate about perspective is, well, for starters, this angular size calculator is also an orthographic view. It is also a side view, but the angular size is if you know the distance and you know the size, you can find the angle. And nowhere in this Metabunk calculator do you put in the size of the object at the far end. So the whole ranting and raving about how this calculator does not take into account perspective is really it's what they call a loaded question. Have you stopped beating your wife yet? Basically presumes that you have been beating your wife. So it's like, how can you answer that with a yes or no answer? Well, you can't. So if someone is asked, does this calculator account for perspective? Well, it sort of presumes that it should account for perspective. Or the question is, why doesn't it account for perspective? Well, there's no need to take any perspective in it. But here's the rub. So this is actually the frosting on the cake. Here's the rub. If you want to know what happened to that diagram, you know what? I think I just totally lost the diagram. All right, I'm not normally a Safari user, so let me maybe hit the reset button. All right, so if you take this diagram and it gives you a certain value for the hidden, and the Flat Earth crew says, oh, this is an impossible sighting on the globe because so much should be hidden by Earth curvature. And they say something like, oh, 300 feet should be hidden by Earth curvature. And it turns out we're talking about a distance of, 40 miles. Well, that's when you should apply perspective. So for example, you want to solve for angle. So actually, let's do this. Oh, my phone is about to die. Let's do this. I'm just going to pull out a calculator real quick. So let's say that they're saying that a sighting is impossible because 300 feet should have been hidden by curvature. Like, let's say it's a lighthouse or something, and it's a distance of 40 miles. All right. I am trying to get to my calculator. So what is 40 miles in feet? So I just want to show you the distance. If you put in 40 and then you put in 300, it's not going to work because the units are not the same. Let me see if I can I zoom in here? Okay. So I'm just faking this total hangout is really, I'm just making this stuff as I go along. But anyway, so this is not going to give you an accurate reading because this is not 40 miles and it's not 300 feet. It has to be the same units. So I have to either put both of them in miles or both of them in feet. So I think it'll be easier just to do 40 times 5,280 gives us 211,200 feet. 211,200 feet. Okay. So that's the distance. And then we have a size of 300. And so if I hit calculate, it turns out that the reason why they're ranting and raving because they can see a lighthouse 40 miles away that should be hidden by 300 feet of curvature, they're ranting and raving by an error of 0.8 degrees. Now, again, oftentimes they talk about refraction as like the looming standard hyena, something or other. And it's really just a bit of obfuscation. It's just trying to confuse the issue. So what I tell people is forget refraction, just run the calculations without refraction, such as you can do with the Earth curve calculator. So the Earth curve calculator is a much simpler diagram. There's no refraction. It just runs the math based on the given value of the radius of the Earth. Okay, it says the Earth is a convex sphere of radius 6,371 kilometers. So there's no refraction in this. And so if you run the numbers with this Earth curve calculator, then you may come up with some impossible sighting because somebody took a picture of a lighthouse that was 40 miles away. And technically, that lighthouse should have been hidden by 300 feet of curvature, but it turns out that 300 feet of curvature at a distance of 40 miles is 0.8 degrees. So what they are staking their entire reputation on, what they are staking their personal knowledge that the Earth is it can't be a globe. I mean, the globe is impossible. We've nailed the last nail in the coffin. And that's because they're not willing to even accept 0.08 degrees of curvature, or 0.08 degrees of, not curvature, of refraction. And the thing is, if anybody has watched the Skunk Bay footage, they oh, and hello, Team Skeptic. Sorry, a little bit delayed. I didn't look at the chat. But, you know, refraction does exist. If you take a look at the Skunk Bay footage, let's see if I can actually pull it up real quick. Let me go to YouTube. If this were a well-produced show, I would have loaded up all these things. Skunk Bay time-lapse. All right, Superior Mirage. So if you take a look at this, and I don't mean to, you know, I don't want to have a copyright strike or anything, but, you know, if you take a look at various places, you know, we see significant motion. Like this camera is bolted down, right? This camera is bolted down, but yet we see significant motion of both the water, the land, the various levels of the land, like this spit of land. There's a little community named something point. That spit of land is a different piece of land than this sort of a medium colored trees, which is obviously different than this bluish section of land here. And then at the very, very back, there's actually a hilltop that appears. I think you could see it right in the very, very beginning. Yeah, there's like a mountain. There's a mountain range in the back. So we're seeing 5 layers. I think there's water, there's the front land, there's the next land, there's this land, and then there's the mountain in the back. And all of these layers move almost independently through this video. So refraction is a thing. But what's amazing to me is that if you run their numbers, if you run the numbers and they're having this, oh, this is impossible on a ball. It's impossible on a ball because it should have been hidden behind 300 feet of curvature. Well, you just go to the angular size calculator and you find that what makes it impossible is 0.08 degrees. And that's not asking for a lot. And in all my experience, in all my calculations, I mean, every time I see some claim that says this is an impossible sighting on a ball, you know, like the world record distance photography, I mean, every single one of those things I sink my teeth into, and I have never seen one that is more than half a degree of refraction. I've never seen more than half a degree of refraction. And so that's my quick little bit about refraction, and not refraction, about perspective. I believe that the Nathan Oakley crew, they mean well when they talk about refraction because they want people to talk about angular size, but there's nowhere in the Metabunk calculator or even this other calculator, the GitHub calculator, that talks about the target height. Target height is nowhere in this calculator. But what is in the calculator is how many feet that is hidden, right? What is hidden behind the curvature that you can plug into an angular size calculator, and you can determine what a degree of refraction would be required. So, and I'm Rick. Oh my goodness, you are so funny. So anyway, this is just a very, very quick chat, but I just want to repeat um, what I was saying in the beginning, back when it was just me and the crickets. Um, is that I would like to start a weekly show, but I don't want it to be an echo chamber. So I would like to have a show, and I will have a guest on that is a flat earther. And I would like to be the exact opposite of that other debate show where there's, just a bunch of screaming and yelling and ad hominem attacks, and this person's retarded and this person's a muppet and shut up, shut up, shut up. All that kind of craziness. Forget all that. Let's have a civil conversation. Let's have a civil conversation with a globe earther. That would be me, and a flat earther. And so I haven't actually reached out. Well, I reached out to one person, so he might be available next Saturday. And the idea is that it's not going to be a massive, like, 4-hour show. It'll be a 1-hour discussion. So one of the things is, since it's only an hour, then we're going to try to keep the topics moving. So those are going to be the basic points of this weekly show. It'll be, I think, every Saturday, and it'll be different times, because what I will do is, once I connect with a guest, I'll say, "Hey, what's a good time for you?" And then we'll just broadcast at whatever time is convenient for that guest. But it'll be a 1-hour show, so it'll, if you miss the show live, then it'll actually be, watchable or listenable later, because it's only an hour. That's one of the things I do like about Nathan's show, is that he breaks it up into 1-hour segments, so makes it very digestible. But anyway, that is yeah. Well, Bullwinkle, it won't necessarily be a debate. Like, a show might be kind of debate like, but the thing is, what they do bring to the what they do bring to the table is a lot of compelling arguments, most of which are misunderstandings. And if they're misunderstandings, it means that there are a lot of people who misunderstand. Like, there would be no flat earth debate if there weren't enough for people to sink their teeth into for the flat earth argument. I mean, it's a big pill to swallow. Like, the sun doesn't set, the sun doesn't set on the flat earth. So you have to kind of set that aside. But once you get past the sun setting, then it's like, oh, it's all about perspective, and it's all about angular size, and it's all about this and all about that. And, oh, by the way, they've been lying to you. So anyway, that's it for me. I'm going to check out now, and I do appreciate all your comments. Sorry if I didn't speak to everybody who was in the chat. Imric wants to be the moderator. So again, thank you again. Oxy, the show is sponsored by NASA. You're a good man, Oxy. Appreciate that. All right. So I am signing off now. Hope to see you on our next show.